Let's see this. They have given that RAM size is 4 gigabytes, okay, 4 GB RAM, and RAM is divided into 64 partitions, okay. Also they have given that we are using fixed partitioning, okay. We are using fixed. Let's see, it's exactly like what we saw in the last video, okay. In the last video also we are supposed to use fixed partitioning. Now let's see this. They are also given that assume it is a byte addressable system. What does it mean? Every byte should be given a unique address. Now how the addressing will look like for such a system? Okay, that's what we need to find out. See, I've already told that what is meant by how we need to convert this 4 GB in terms of 2 power, so that it will be very easy. Okay, 4 is nothing but 2 square, right? 4 is nothing but 2 square. GB is nothing but 2 power 30 bytes, right? Gigabyte, 1 gigabyte is nothing but 2 power 30 bytes. So 2 power 2 into 2 power 30 is nothing but 2 power 32 bytes. Okay, 2 power 2 into 2 power 30 is nothing but 2 power 32 bytes. Now tell me one thing. Now in case if I have 2 power 32 bytes, and in case if I give an address for every byte, now how many bits do I need? So in order to address 2 power 32 bytes, I need exactly 32 bits. Okay, in order to address 2 power 32 bytes, I need exactly 32 bits. Now how did I get this 2 power 32 bytes? It is very simple. Okay, you need to take log base 2, which means log of 2 power 32 base 2. Now this 32 can come here. Okay, so 32 into log 2 base 2. Log 2 base 2 is nothing but 1, and so I can say that this is 32. From this I got that in order to address 2 power 32 bytes, I need exactly 32 bits. And so our address will have a length of 32 bits. Okay, our address will have a length of 32 bits, or total address. And they have given that our RAM is divided into 64 partitions, 64 equal size partitions, and all of them are fixed. Okay, fixed partitioning. Now in case if I divide 2 power 32 bytes by 64 bits, 64 partitions, how many bytes will a single partition have? Okay, 64 partitions. Now this 64 can be written as 2 power 6, right? This is 2 power 32 and this is 2 power 6. And what is the unit here? For this it is bytes, for this it is partitions, and so I can say that unit for this is bytes per partition. Okay, bytes per partition. What does it mean? For a single partition, I will have these many bytes. Okay, so 2 power 32 divided by 2 power 6 is nothing but 2 power 26. So 2 power 26 bytes per partition. What does it mean? Every partition will have exactly 2 power 26 bytes. So from this we can say that, see, how many partitions do we have? We have 64 partitions. Now in order to address 64 partitions, how many bits do I need? We need exactly 6 bits, right? So first 6 bits I am going to actually use in order to indicate the partition number. Okay, I am going to indicate the partition number. And out of 32, in case if I leave this 6, how many bits will this have? This is nothing but 26, right? So these 26 bits are actually going to indicate the byte number within a partition. There are 64 partitions, okay, and these 64 partitions are addressed by using the 6 bits. Now once I reach a particular partition, within that partition, how can I refer a single byte? For that I use this 26 bits, right? This can be calculated this way, which means 32 minus 6 is nothing but 26. This is simplest way. Another way to do this is by using this method, right? In order to, there are 2 power 26 bytes per partition, which means within a partition there are 2 power 26 bytes. Now in order to address this 2 power 26 bytes, assuming that I am giving a single address for every byte, I need exactly 26 bits in order to address 2 power 26 bytes, right? And so I am going to use this last 26 bytes in order to address the bytes of a single partition. Okay, so this is how the addressing will look like. Okay, so I want you to be more comfortable with this. Okay, so you can take some random numbers, you can replace 4 GB with 8 GB, and you can convert you can you can modify the question of 64 partitions as 128 partitions. Anything you can take, okay, anything, but you take it in terms of 2 power, okay, because in computer science everything will be in terms of 2 power. For example, 64 is 2 power 6, 4 GB is nothing but 2 power 32, okay. See, and one more thing, you should be very comfortable with this logarithm, okay. In case if you are not very comfortable with logarithms, you just go through the basics of logarithms. For example, log base 2 is very important. Coming to computer science, log base 2 is very important, okay. Log 2 base 2 is 1, log 4 base 2 is 2, log 8 base 2 is 3, log 16 base 2 is 4, log 32 base 2 is 5, log 64 base 2 is 6, log 128 base 2 is 7. You can keep on going like this, okay. At least be very comfortable until log, say, at least 2 power 12, okay. At least 2 power 12, 2 power 13, you should be very comfortable. This is 2 power log 2 power 1, this is log 2 power 2, 2 power 3, 2 power 4. Be comfortable until log 2 power 12, okay.